All right, guys, we are on day 8, and we're going to talk about solving equations, but they will have imaginary roots. So we've been solving equations with real roots. We solved equations with real rational roots. We've solved equations with real irrational roots, and now we will solve equations with not non-real or imaginary roots, okay? So just a little recap about roots, okay? They're also known as zeros, okay? They're also known as x-intercepts. Okay, or where the graph crosses the x-axis. All right, roots and zeros of a function are also known as solutions to the equation when it equals 0. All right, so again, roots are also where the function crosses the x-axis, known as x-intercepts. We've talked about real roots before. Real roots you're going to actually see lie on, or they can actually be seen on the x-axis. So when we have a graph, okay. We could have let's go with just a parabola, right, or a quadratic, cross the x-axis once here and once here. And because you can really see them, these are real roots. All right, we could have roots that are known as rational and unequal. Okay. We could have roots that are known as rational and equal, which is known as the double root. Okay. Or we could have roots that cross at not nice numbers, unlike rational, and they're called irrational and unequal. Okay, so going back to the top one there, rational and unequal, the graph will cross the x-axis 2 times at what we call nice spots, since they're rational. Okay. If we have rational and equal, also known as the double root, then your parabola or your quadratic will just touch the x-axis and bounce back up. And so right here, that's called tangent to the x-axis. And there are 2 roots there. It's just that they're exactly the same, or they're equal. And so if we have a double root, the graph will just touch the x-axis at one nice spot because it's rational again. All right. And then we have irrational and unequal, and the graph will cross the x-axis still 2 times, like the red parabola that I graphed there, but not at graph will cross x-axis 2 times at 2 not nice spots. I guess we have the number 2 in there again. So hang on, let me erase that and put 2 in there. Okay, so 2 times at 2 not nice spots. All right, for instance, it crosses at, let's say, square root of -5 and square root of +5 or something like that. Okay, and then we have what we're going to talk about today, which is what they call non-real or imaginary or complex roots. And this graph will not cross the x-axis, okay, nor touch. All right, so graph will not cross nor touch the x-axis. So let me show you what that looks like. All right, so if I draw you a little scrap graph off to the side, a quadratic that has imaginary or non-real or complex roots, notice this is what he looks like. He's floating. All right, you will not see him touch or cross the x-axis because those would be real roots. And so this still has 2 roots, but they're imaginary. They have eyes in them, okay? And that's what we're going to solve for today. All right. Your parabola, guys, could also look something like this, where it floats below the x-axis, but again, it is not touching that x-axis whatsoever. So if you ever see a quadratic where it doesn't touch the x-axis at all, okay, or cross it, then those are what they call non-real. All right. All right, let's go ahead and take a look at the bottom here. Okay, so in number 1 and 2, it says solve the following equations. So we know we can't solve quadratics, okay, or any equation, unless it's equal to 0. And so that is always our first step, whether we're going to factor, complete the square, or quadratic formula to solve for our 2 values of x, because these are all x squared terms in these questions or equations. So in number 1, I'm going to go ahead and subtract the 6x. And when I subtract the 6x, I know that becomes the middle terms. All right. And so there we go. All right. So we could try to factor it. but I don't think that it's going to work. If I go ahead and factor it, I'm looking for numbers that multiply to 13 and add to -6. And the only numbers that multiply to 13 are 13 and 1, and that's not going to give me an adding of -6. So factoring's out of the question. I have two options left. I could complete the square, or I could use the quadratic formula, and I think by now we know that quadratic formula is a little bit user-friendly than completing the square. And so we're going to go ahead and state our values. Our A value is 1, our B value is -6, and our C value is 13. And so now we can go ahead and use the quadratic formula. If you don't remember it, it's on your reference sheet. And so we'll go ahead and say x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so remember that's always our first step. Our second step is to clean it up, especially when we have two negatives like that. That really makes a +6. Plus or minus the square root gets a little bit shorter, and all of this underneath it goes into your calculator. Make sure that you use parentheses around the -6, okay? And when we hit enter, we should end up with -16. And this is the first time we've ever ended up with the quadratic formula with a negative underneath our square root. And hopefully you guys remember from day 6 and day 7 when we did it. But we're going to have to go ahead and simplify that radical and with the negative underneath it. Because 16 is perfect, we'll just break it up into two houses, one being 16 and one being -1. And remember that that's going to give us the 4, and this is going to give us the I. And so we'll now, in step 3, rewrite this with that being replaced. So we'll end up with 6 plus or minus 4i all over 2. Okay? And then we'll go ahead and do our very last step, which is the little heart pretzel. All right, to simplify not only the 6 divided by 2, but also the 4i divided by the 2. And so our final answer will be 3 plus or minus 2i. And there is our imaginary or complex or non-real roots, okay? One of our roots is 3 plus 2i. That's one value of x. Our other value of x is 3 minus 2i. And these are always going to actually be conjugates of each other. Okay, so when we have non-real roots, the two roots that we get from solving are always going to be conjugates of each other. All right, just so you guys know. All right, and that one's finished. So let's go ahead and head to the next one. All right, so again, in order to solve for these two answers, whether they're real or non-real, we have to make sure that our equation is equal to 0. And right now we're not, so we're going to go ahead and subtract the 12x. And we're going to go ahead and subtract the 5. And when we're finished, we'll be equal to 0, and we have 8x squared. 36x minus 12x is 24x. And 24 minus 5 is a positive 19, and we're equal to 0. Okay? We could try factoring if you wanted to. This is a hard trinomial. There is no way out of it. You can't pull the 8 out of 19, so that's not possible. In fact, there's no number you can pull out, and so you're left with a hard trinomial. And so you could try to factor it if you wanted to, but based on the topic of today, it's imaginary. It will not be factorable if it has imaginary roots. And so we're going to go ahead and say our A value is 8. Our B value is 24, and our C value is 19. And now we can go ahead and plug them into the quadratic formula. So we have x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right. We'll clean it up a little bit. That's going to stay a -24. Plus minus, square root gets a little bit shorter. All of that underneath the square root goes into your calculator, and when you hit enter, you end up with -32. All over 2 times 8, which is 16. Okay? We're going to take that square root off to the side. 32 is not perfect, so we'll actually have 3 houses. The largest perfect that goes into 32 is 16. The other number is 2, and then we'll have the house for the negative, okay, which is really a -1. Okay? We know that the square root of 16 is still going to be 4. The square root of the -1 becomes the I, and then the square root of 2 comes down, and then in our next step, we'll replace that. So we'll end up with x equals -24 plus or minus 4i radical 2 all over 16. And then we'll go ahead and simplify the fraction by dividing here and by dividing by there. And we end up with -24 divided by 16. is negative 1.5. But a lot of times when we do these, we try to use fractions just because it starts off as a fraction. We try to keep it as a fraction. And so that'll be negative 3 over 2. We'll keep the plus minus in between. And then when we do 4i radical 2 divided by 16, it's really the 4 and the 16 that get reduced. And 4 over 16 is 1/4. Okay, so you can either keep the 1 there or you don't technically need the 1 there because you have the I radical 2 still there. So we'll go ahead and say I radical 2 all over 4. Okay, if you want to see the 1/4, remember there is a 1 technically there, but you don't need to put that 1 there unless you want to. Okay, so it's up to you. And there is our complex roots, okay, or our imaginary roots or our non-real roots. And they're all because of that I that is in that answer. All right. All right, guys. Let's take a look at number 3 on the bottom here. And it says, which of the following quadratic functions has non-real solutions? All right. So as soon as we see non-real, we're thinking the parabola is what I call floating. It's not going to be touching the x-axis. It's not going to be crossing the x-axis. And so the easiest way to do this question is to use our graphing calculator and to get the picture. Or you could use the quadratic formula 4 times and see which one ends up having an I in their answer, which I would say is probably not the easiest way to go. All right, so I'm going to grab my calculator. In y equals, I'm going to type in the equation in number 1. And I'm going to graph it for you. And in fact, I'm going to graph all 4 of them for you. Okay. And I'm going to draw you guys a little picture about what I get. All right. So in number 1, when I graph that, the picture I get looks something like this. Okay. And right there is 2 real roots because I really see them on the x-axis. And therefore, these are real roots, not non-real. Okay. In number 2, when I graph number 2 in my graphing calculator, my parabola looks like this. And right here is a real root, and here's a second real root. And so these are real roots because you really see them cross the x-axis. Okay. In number 3, okay, when I graph number 3, my parabola looks something like this. And you guys can see right here, that's what I mean by floating. It has no x-intercepts, but it still has x equals solutions, okay? It's just that they're going to have I in them, and they're going to be imaginary, which is the same thing as what non-real is. And so choice 3 is my answer. But just to show you choice 4, okay, if I graph that in my calculator, I'm going to get a parabola that looks like this, and there are 2 real roots right on the x-axis. And so these ones are also real. Okay, number 3 is the only one that has non-real roots, all right, or complex roots or imaginary roots. Okay, all right, guys, I'll see you on the back side of notes.